And welcome everybody. It's great to have you here. You know what's more fun than configuring Cisco gear? Gosh, there's a short list probably. There may be one or two things above that. But our objectives in this video is to provide you with a packet tracer lab that'll have the opportunity for you to practice switching and routing and trunking, DHCP, DHCP Relay, and more. So my name is Keith Barker. If you're brand new to the channel, hey, welcome. It's great to have you here. I am recording this for a live premiere that's going to happen at 4 p.m. today. It is 9:13 and I have another meeting at 10 o'clock. So hopefully I can do this walkthrough of implementing the solutions for this packet tracer lab in less than 30 minutes from soup to dessert. I'll just leave the camera rolling. So it's great to have you here. If you are new to Cisco or if you're new to this channel and you want to peruse the master playlist, please visit the channel. There's a Cisco 200-301 CCNA master playlist. Just go through that list. It's got a lot of great content, including it'll cover a lot of many of the technologies that we're going to use today as we build this packet tracer lab. So let me introduce you to where you can get the lab and then also where you can download it so you can practice it, and then I'll do the walkthrough together with you. Let's take a look at the topology. Let me move my mic over a little bit, and a question might come up and say, well, packet tracer, where do I get it? You get it from netacad.com, and it's a Cisco educational site. You can get a free sign in for free and then download it for free, and you got packet tracer. And then as far as this lab goes, I have 4 PCs here. Let's see here. Get my pen out. I've got 4 PCs, PC 1, 2, 3, and 4. I've got a server that's acting as a web server and a DNS server. I've also got this multi-layer switch and these 2 access layer switches with the ports involved in between them. And a person could just drag these up from the topology and create this topology, or we could start with this framework, which is what I would encourage you to do. And in that light, what I've done is I've made this available so you can download it right here from the keithbarker.com. And that web page looks like this. Well, part of it does anyway. So this is the keithbarker.com, and there's a section for downloads, or you can just scroll down either way you want. Yeah, and this is the lab right here that we're going to be focusing on. Let me make sure it's in frame. It is, great. So this is the lab right here. Cisco PT OGIT for the original gangster of IT. 2020-04-07, that was the date that I actually put that framework together, that lab. And you just click on this download link right here, and it'll download that lab file to your computer. So if you have packet tracer installed, you can go ahead and open it and start where I am right now. So our objective in this lab, and I put the, in that download, it has a PDF with all the instructions. I also put, I love this. I also put the instructions right here in the lab so you can actually look at it and see the instructions as you go through. And basically the goal is this. We want PCs 1 and 3. Let me get out the right pen here. We want PCs 1 and 3. That's this guy and this guy. We want them to be in VLAN 10, which means that the access ports here on the switches are going to be associated with VLAN 10. And the subnet for VLAN 10 is 10.16.0.0/24. And if you're brand new to IP addressing and subnetting, all the rest, check out our Subnet Saturdays. It's also part of the master playlist on the YouTube channel. Okay, so 10.16, that'll be VLAN 10. And then for VLAN 20, which I'll put in a different color, for VLAN 20, we have PCs 2 and 4. And that subnet is 172.16.0.0 with a 24-bit mask. Great. DHCP assigned addresses for these PCs. This is our DHCP server right here. And let's see here. DHCP and web server is in VLAN 777. So let me put yet another color here. So VLAN 777. And let me go back and document this to 20 and 20, and then go back. So VLAN 777 and this server, and this is the 777 is the 192.168.1.0 network with a 24-bit mask, and they want to use .100 for the server. Okay, so what helps me when I'm working on a lab is that yesterday I put this together. And I'm about to implement the configuration on top of the infrastructure or the underlay, but it also helps me to write it out, or just what I'm doing right now. And so if you want to take a separate piece of paper and pause, or when you're doing the lab, just write it out so you're clear on what goes where. The carpenter's rule is measure twice, cut once. And if I have had this happen more times than I am care to admit. And then I'll rush into something and I'll put the wrong address on it, or I'll have the wrong subnet in mind, or the wrong default gateway, and it'll be a problem. So just document it, take your time planning, and then go ahead and implement it. All right, so DHCP web server is on VLAN 777, subnet's that, and it's .100, great. The default gateway is .1 in each subnet. All right, so that means the default gateway for VLAN 10 is going to be .1. The default gateway, I'll put gateway here, we'll document that. The default gateway for VLAN 20 is going to be .1. The default gateway for 777 is going to be .1. Now I'm looking at this topology, and it doesn't really say who the router is, but I know who the router is going to be. The only device here that has routing capability for other devices is this guy right here. That's going to be the router, which also means that this device, this multi-layer switch, we're going to have SVIs, switched virtual interfaces, one to support VLAN 10, one to support VLAN 20, and one to support VLAN 777. And it's going to have a .1 address on each of those interface VLANs. So if you're new to interface VLANs or SVIs, check out those videos in the master playlist as well. All right, and then I'm going to go to my pointer so I can scroll up just a little bit here. And it says verify clients can ping each other, and verify clients can open up the web page of the server at thekeithbarker.com. All right. Well, I'm going to leave that marking in the background, and let's go to work and let's configure. And I think I'm going to bring up one of my favorite tools to do this, and that is Notepad. And actually, maybe I won't leave all that up there. We'll see. Let me see. Make sure we can see this. All right. There are certain things. All the devices are on their default configuration. The server has a little bit of information on it, but the switches and the PCs are all their defaults. So here are a few things that I probably would do on a brand new networking device if it was Cisco. And that'd be, I'd go into configuration mode. I'd do a no IP domain lookup, making sure my head isn't on top of that. Okay, and then what else are we gonna do? How about line console 0 and logging synchronous? I'm just putting shortcuts there. And then also no exec dash timeout. Because in a lab environment, I don't want to have to log in and log out all the lot. Just put me in. And also privilege level 15. So I just connect to the console. It puts me in privilege level 15 and I'm good to go. There's no login there by default, so that's good. What else? All these are going to be, these three switches are switches, so I might as well do this. I'm going to exit. I don't have to use the exit. I can just jump, but the exit there for you and I just realize that we just jumped out of line configuration mode. And let's do spanning tree mode rapid for rapid spanning tree, and let's also do spanning tree port fast default. I'm just doing some of the shortcuts here, but that way my clients, when they connect, if I have to bounce an interface, it won't be a long time before they come in. And let's see what else I might want to do. No IP domain lookup, logging synchronous, no exec timeout, privilege level 15. And how about a host name? Yeah, and then I'll just take that and I'll start there with each of the devices. So I'll just copy that, right click, copy. And let's go configure switch 1. So there is switch 1, and I'll bring this over to the right a little bit. And I think I will hide just my writing for a moment, and we'll come back to that if we need to. So this is switch 1, making sure we can all see it. I'm going to go to the CLI, enable, and then I'm just going to do a right click and a paste, and I'll call that SW1. And I'll save that. WR is a shortcut for write memory, or in the old days when I was a young whippersnapper, that's a shortcut for copy, run, start. That takes your running config and saves it to the startup config. All right, and we'll go to switch 2. And once we have these dialed in, by the way, we'll just tab between go between these interfaces, these devices, and we don't have to resize it every time. So I'll right click here, and it's on switch 2, paste. And just confirming which one I'm on. Switch 2 is right there, and we'll call it switch 2. And then we'll go to switch 3. And go to the CLI. Enable. And paste. Okay. All right, so we've got some basic comfort food, comfort commands on our switches. Let's next set up the infrastructure. Let's set up trunking. Okay. So these interfaces here, if you don't want to see them all the time, you can go to Options, and we can go to Preferences, and we can select, instead of always show port labels, we can do turn that off. And then you can have this option over here, show port labels when you mouse over them. So I'm going to leave them up for now unless they get too busy, but I think this isn't too bad. We can still see where they're at. And let's configure our trunks and our VTP and our VLANs. That's all important. So let's bring up Notepad again. And you don't have to use Notepad. I'm just doing it because it's going to be a little bit more convenient. So we did all that. I'm going to get rid of it so I don't do it again. And I'll go into configuration mode and we'll say VTP. They're going to be servers by default. So we'll say VTP domain, OGIT. And that'll allow us to replicate our VLANs. And if we have trunks, so let's do that too. So it'll get an interface on these two switches, switch 1, switch 2, interface range FA 0/11, FA 0/22. That'll put us into interface configuration mode for those two interfaces, and we'll say switch port mode trunk. So if you have a device that supports ISL, which is really old, or 802.1q, you could say switch port trunk encapsulation.1q, and then that would tell it what type to use, and then you could say it's the trunk. And for switch, okay, I'll make it clean. So we'll do this real quick, and let me also, so this would be on just switch 1 and 2, and I'll go switch 1, right click, paste. All right, and go to switch 2 and paste. Okay, and then on switch 3 it's going to be slightly different, so we can just do that manually. I got these gigabit interfaces too. They both have gig 0, 1, and 0. Okay, you know what? We have gig 0. Can't forget any of these ports. So let's do this. I am going to erase my old work and start new. So I've got, give me one moment. There we go. I've got this interface, gig 0/1 and 0/1 and 0/2 and 0/2. And if I just made a script that said, okay, 0, 1, and 0/2 are all going to be trunks, and well, you know what? I'll just do it manually. I'm trying to save time, but it takes more time to explain it than just to do it. So let me just go into interface configuration mode and do it. So here on switch 1, we'll go into interface gig 0/1, switch port, mode, trunk, done. And we'll do the same thing on switch 2 for gig 0/2, config T, interface gig 0/2, switch port, mode, trunk. And then we'll go to switch 3. And on switch 3, we need to configure its all right, do it this way. All right, so on switch 3 is we need to do gig 0, 1, and 0/2 as trunks. So we have videos on trunking in the master playlist for CCNA. Check that out if you're new to trunking. And interface range gig 0/1 through 2. That'll work. And then switch port, trunk, encapsulation. Okay, so this multi-layer switch perhaps supports more than just one trunking protocol. So I'm going to specify .1q as the standard, and then we'll do a switch port, not storm control, switch port, mode, trunk. And then we should be able to create our VLANs, and they should show up everywhere. So VLAN 10, VLAN 20, VLAN 777, show VLAN brief, and let me spread this out a little bit further. There we go. All right, so I've got VLANs 10, 20, and 777. I have no active access ports in it, but if we do a show interface trunk, I am supporting on my 2 trunk ports all those VLANs. So we are good to go. We've got the VLANs, and because VTP was enabled, by default, and we set up the domain. If we go to switch 1, we should have the same VLANs there. Show VLAN brief. Sure enough. I was expecting those VLANs to be there. Oh, did we not make switch 3 part of that domain? Hold on a second. Show VTP status. Yeah. We didn't make this. We didn't make. I didn't make. We didn't do this. I didn't make switch 3 a VTP member in that domain. So we'll just fix that. Config T, VTP domain, OGIT. All right. So now we have trunking. We have a domain set, and let's see. Let's do a show VLAN brief. Okay, we didn't lose the VLANs. That's good. And let's go to switch 1 and see if they're there. Not yet. It's OGIT. Okay, I'm going to do this. This is very real. I'm going to bounce it by just adding a new VLAN. That'll increment the counter and config T, VLAN 999, exit. It's the exit as when that VLAN actually becomes active. And let's go take a look at switch 1. Show VLAN brief. Okay, see, this is kind of like jiggled it loose. If we had waited a few minutes, it probably would have synchronized as well. We no longer need VLAN 999, so I'm going to get rid of it. No VLAN 999. All right, and if we go back to switch 1, we'll show VLAN brief. All right, now we're cooking with gas, and we'll go to switch 2 and make sure he's all happy to show VLAN brief. Sure enough, all the VLANs that we need exist. All right, so let's take a look at our playbook here. PCs 1 and 3 need to be in VLAN 10, so we're going to need to go to these two ports, FA0/1 and F on switch 1, and FA0/3 on switch 2, and assign them to be in VLAN 10. And we also need to assign FA0/2 for PC2 and FA0/4 for PC4 to VLAN 20. So let's do that. That's going to be important to make this work as well. So we'll do it. Let me go to switch 1. And here on switch 1, we'll just do a config T interface FA0/1 switch port mode access and switch port access VLAN 10. And then we'll go up to FA0/2. Do the same thing again, except we'll put it into VLAN 20. Show VLAN brief. Always verify our work afterwards. And great, so our 2 ports are assigned correctly based on our plan. Let's go to switch 2. On switch 2, we're going to put the 2 respective ports into VLANs 10 and 20 also. So config T and interface FA0/3 switch port mode access and switch port access VLAN 10, and we'll go to, oh, that's the wrong port. So we're not even using port FA0/2 here. It's FA0/3. All right, let me do this just to bring it back to normal. Default interface FA0/2. Boom. Just setting it back to what it used to be. All right, interface FA0/3 is where we want to go. And we want to do a switch port mode access, a switch port access VLAN 10. And then we want to go to interface FA0/4. Make it an access port, and make it in VLAN 20. And then we'll verify our work. Show VLAN brief. All right, so I've got those 2 ports properly assigned. All right, super. I think we're in, oh, and also this server right here, this server that's hanging off of FA0/5 needs to be in VLAN 777. So let's do that too. So config T, config T, interface FA0/5, and wow, look at that, 5. And switch port mode access, switch port access VLAN 777, and we'll verify our work there too. Show VLAN brief. Those look great. Okay, all right, we're making progress here. All right, we got a few minutes on the clock. We're still doing good. We have our trunking set up. We have our VLANs created on all the switches. We have the access ports assigned for the 4 PCs and for the server. What else is on our list? Oh, they're going to need IP addresses, and they need to be DHCP assigned addresses. Okay, so we need to create scopes, as they would be called in Microsoft DHCP, or pools of addresses that the DHCP server can hand out. Now, this server is over here in VLAN 777. So we're going to need some DHCP relays on the client's local network so they can actually get those requests sent over to the server. We also have videos in the master playlist on DHCP Relay as well. So here on the server, on this DHCP server, also acting as a web server, what we'll do is we'll click on services. Oh, let's check out its IP address too. So if we go to config and go to fast Ethernet 0, it has the right address. That's good. 192.168.1.100. And if we go to settings, its default gateway is .1. Good. It needs to be able to communicate off of its local VLAN 777, which is the 192.168.1 network. All right, so let's go ahead and click on services and checking my feedback monitor there. Great. So on services, and we're looking at this server right here, let's go to HTTP. We're going to need that later. So HTTP services are working, or at least they're enabled. And DHCP, it has this default server pool, but we need, it's not the right addresses though. We need two pools of addresses, one for the 10. What network was it? One for the 10.16.0 network and one for the 172.16 network. So let's go ahead and create those. And here's how you do it right here in Packet Tracer. First of all, we're going to turn on the service. Otherwise, it won't work. And then we'll go ahead and we'll say our pool. I'm going to call the pool VLAN 10, just so when I see it, I'll know what it is. The default gateway for VLAN 10 is going to be 10.16.0.1, based on our plan. The DNS server is actually the server. And that server is at 192.168.1.100. It's acting as a DNS server and a web server and a DHCP server. And we can also verify the DNS service as well right here. So it's running DNS. All right, back to DHCP. Oh, great. I didn't save my work, so no problem. Round 2. All right, VLAN 10. And VLAN 10's default gateway is 10.16.0.1. That's why it's good to have it on paper, referenced. You know where you're going. The DNS server is 192.168.1.100. Great. Nope. Yep. That's it. And I got to take these in order so I can make sure I do it right. So the starting address for this DHCP pool that we're creating is 10.16.0. I'm putting in periods. Many operating systems use 10. It skips you over. Packet Tracer is making me maybe tab over. So 10.16.0. And I'm going to start my first IP addresses at 10, just because we can. I'm going to and the mask is 24 bits. That's great. Join us for Subnet Saturdays for more on IPv4 addressing and masking and subnets. And the maximum number of clients, I'm going to just do 10. We're only going to need 2 in each subnet. 10 is going to be plenty. And then here's the important part. I got all that information in, add. And that adds that pool. So let's verify our work. 10.16.0.1 default gateway. DNS server is the server. Starting address is .10. Great. Let's make one more for VLAN 20. One more pool. So VLAN 20 is 172.16. We'll start at 10 there as well. 24-bit mask. Default gateway is going to be 172.16.0.1. That's important. DNS server is the same. Click on add. And now we have 2 pools. One for VLAN 10, one for VLAN 20. All right. And it's enabled. So the server looks good. Let's make sure from the server we can ping. Oh, I was about to say, let's make sure from the DHCP server we can ping. And then I realized we don't have any IP addresses on any other devices yet. So there's nobody out there to ping yet to verify basic connectivity. So let's tackle the multi-layer switch, which is going to need 3 VLAN interfaces. One for VLAN 10, one for VLAN 20, one for VLAN 777 with the appropriate IP addresses. And then we should be able to ping from the DHCP server and the web server on that local network. We should be able to ping one of those interfaces. Let's do that next. All right, so back to our topology we go. Here on switch 3, we are going to create 3 SVIs, switched virtual interfaces, logical layer 3 interfaces. Again, we have some videos in the playlist on exactly what that is and how that works for all those details. Let's do a show VLAN brief. Let's do a show IP interface brief. I want to see what layer 3 interfaces we have so far. And this says that we have, so we have no IP addresses. There's nothing IP address-wise here. And this also shows VLAN 1 is administratively down. I'm not using VLAN 1, so I'm not even going to worry about that. So we'll just do a config T, and we'll create interface VLAN 10. This will support and be a logical layer 3 interface for any device that's in VLAN 10. And we'll give it the IP address of 10.16.0.1 because that's the default gateway that we're handing out from the DHCP server. And we'll put a 24-bit mask on that. and that's how you spell a 24-bit mask in dotted decimal. And then we'll create interface VLAN 20, and we'll do an IP address for 172.16.0.1, the first IP address in that IPv4 subnet, and a 24-bit mask. And one for 777, VLAN 777. So interface VLAN 777, IP address 192.168.1.1 with a 24-bit mask. All right, and then the key thing here, my friends, is to verify our work. Show IP. This gives us a chance to verify that the commands took, there wasn't an error, and also to remind ourselves of what those addresses were. Show IP interface brief. And if we scroll all the way to the bottom, we have these 3 logical layer 3 VLAN interfaces supporting their respective VLANs and the clients in those VLANs. The addresses all look correct. Now, what we should be able to do, because we have the logic on this is, as I look at my clock, oh yeah, we're good. So the logic on this is this server is in VLAN 777, and it's got the IP address of 192.168.1.100. This switch 3 has a logical interface in VLAN 777. It's called interface VLAN 777, and it's got the IP address ending in .1. So we should be able to ping back and forth between those. And yeah, let's start there, one step at a time. So let's go and let's go to switch 3 and so ping to our server at 192.168.1.100. All right, and that first ping usually drops on a Cisco device because of ARP. The ARP, it does an ARP request and basically fails to even send that first ICMP echo request because it's doing the ARP. And then the second one, we should get 5 out of 5. Great. And we should also, from this server, all right, well, let's, there's lots of cool things we could do here. Let's continue on with our configuration. Next, we need to give these clients IP addresses via DHCP. So to do that, what we can do is we could try, if we just hover over those devices, check it out. If we hover here, well, let's go configure it. Oh, look at that. Okay, it has an IP address. I wasn't expecting it to have an IP address, but that must be because of the previous config. So let's go to config on PC1, and we'll click on interface, and then below interface, FA0. Oh, it's statically assigned. So if we want a DHCP assigned address, we click on the DHCP radio button, and that goes through the DORA process, discover, offer, request, acknowledge, except in this time it got a 169 address, and that is because there's no local DHCP server. And we don't have a helper, a DHCP relay agent on VLAN 10 forwarding those requests over to the real DHCP server. So we have another whole video in the playlist, master playlist, on DHCP and DHCP relay. Check that out if you need some backfill on that. But the short story is we need to configure IP helper addresses on VLAN 10 and VLAN 20 so that clients on those networks can have their discover messages shipped over to the DHCP server, who can then respond back through the relay and make it work. And that happens on the routers in those VLANs. And in our case, our switch 3 is our multi-layer switch acting as the router. So we'll go to configuration mode, interface VLAN 10, and we'll say it's DHCP relay, but the syntax is IP helper, I think. Yeah. Oh, I see. There's 2 options. IP helper address, and then we point to the IP address of the real DHCP server, so we can route those packets over to that server. So it's 192.168.1.100. Great. And we'll do the same thing for interface VLAN 20 and IP helper address. So basically now, any clients on VLAN 10 or VLAN 20, when they do their discovers for a DHCP server, those can be packaged by switch 3 on the associated VLAN, shipped over to the DHCP server, who can then relay those back through the IP helper function back to the clients. So the DORA process still happens from the perspective of the client. It's just the back half is being routed back and forth between the helper and the server. So let's see if that worked. Let's go to PC1, and it still has an IP address that says it's no good. Let's click on static. Take a breath, and then click on DHCP. Yeah, it got a 10.16.0.10. Great. We'll do the same thing for PC2, which is in VLAN 20. It should get a 172.16 address. We'll go to config, fast Ethernet, click on DHCP. It's working for both. So it's going to work everywhere. So get a PC3. If it's working for those two if it's working for those two VLANs, that means we're in good shape. PC3, DHCP, and PC4. Oh, DHCP. Cool. So if this guy PC4, if everything's working correctly, we should be able to ping PC1 from PC4. So let's go ahead and just, that guy's 10.16.0.10. Let's go to PC4 and verify we can ping him. Desktop, command prompt, ping 10.16.0.10. Oh, so close. So close. All right. Let's see if we can ping our default gateway, IP config. Our default, let me break it, make it a little bigger. Our default gateway is .1. Let's make sure we can ping him. 10.16.0.1. Okay, and let's do this. Let's make sure we can ping the other side. Let's do a ping 10.16.0.1. All right, I know what this is. So the PC, its default gateway is working. It can reach and forward packets to non-local IP addresses. But Switch 3, check this out. If we do show IP route, see how it doesn't show you the routing codes or anything? Even though it's a multi-layer switch, and even though we have SVIs on 3 interfaces, IP routing is not enabled on this switch. And I didn't intend that originally, but that's what's happening here. So if we go to config T and to enable IPv4 routing, it's IP routing. That's the command. So show IP route. All right, so now we have a routing table. Before, the switch was not willing to route packets on behalf of other devices. So if we go back to PC4 and we hit the up arrow key a few times and try to ping 10.16.0.10, oh, there we go. Okay. So that first ARP, if the switch needed to go ahead and do ARP for that final destination. All right, there we go. And as a last test, let's go ahead and on the PC, we'll go to PC3. We'll mix it up a little bit. We'll go to desktop and go to web browser. And the goal is to be able to go to thekeithbarker.com. That's in the instruction for the lab. And there it is. I'd like to thank Dan on the Discord channel and also on the YouTube page for creating and customizing this packet tracer web server for me. I was just blown away. I thought, I'm going to use that. Can I use that? He goes, yeah. So what's happening behind the scenes is that when any of these clients go to this URL, it's using DNS, and the DNS server is the web server. It's got an A record that's for thekeithbarker.com that points to the web server, and that's why this is working. So there's a little mock image of thekeithbarker.com. You can also go there on the real web to download this lab if you want to practice it. There's the ogit.com, the playlist on YouTube. And then there's the a Discord server as well. I've got links for all those in the videos as well for all those resources. All right. So that is that's the packet tracer lab I wanted to present to you and give you a chance to practice and play with. Because it's not troubleshooting, there's really not a spoiler alert. It's more of a, hey, here's a way to practice. Let's see, DHCP, DHCP Relay, access ports, trunk ports, routing, SVIs, multi-layer switch, all of it right here in this teeny little packet tracer lab. So have a lot of fun with it. If you were able to complete this lab and do it and walk through, just post a note associated with this video saying, hey, I completed the lab, and I'm going to have more of these as they come up. If you haven't yet joined the channel, please do so. Click on subscribe. We'd love to have you here and participate with you. I drop videos, new videos, premieres 2 to 3 times a week consistently. That's happened since October of 2019. And I'm just adding those to the master playlist. I'm going to be replacing a few videos as well. My hope for you, as we focus 100% here on this channel on CCNA 200-301, my focus, or in the future if they rename it, my focus is the technologies associated with Cisco CCNA level technology, the meat and potatoes of networking, and I have a blast doing it. So thank you for your participation. Thank you for watching. If you like the video, hey, click on that thumbs up, let other people know, and I'll see you, my friend, in a future video. Thanks, and bye for now.